Hi, I'm Danilo. I'm Chief Evangelist for Amazon Web Services in Europe, Middle East, and Africa. And during this session, I'd like to walk you through a few of the features that we launched more recently to help you understand the behavior of a serverless application. And during this session, there will be only this slide. The idea is to use a very simple application and understand that even in a simple use case, a serverless application has lots of moving parts. It's a distributed architecture. So you need to set up an observability strategy that allows you to understand the behavior of the application and drill down in case something unexpected happens. So I'm using a sample order processing app similar to the architecture that I've seen being used multiple times by our customers. And there are 3 Lambda functions. 2 are behind an API gateway, and you can post an order to create a new order, or you can use an HTTP GET to get the status of an order. When you create an order, I'm just doing a quick syntax check in this first Lambda function, and then I'm writing the order in an SQS queue, and then there is a backend Lambda function that is processing the orders, taking more time. Actually, in this simple demo, it's still fast, but the idea is to reproduce what normally happens with real applications. You have a very fast online front end where you can't wait for even just for a few seconds. So you write the orders in a queue to decouple the real-time front end from the backend, and then in the backend you process the orders, do all the fraud checks and whatever, and then you update the status of the order on a database. Here I'm using a DynamoDB table where the read order function is reading the status of the order. So 3 Lambda functions, an API gateway endpoint, an SQS queue, and a DynamoDB table. Let's deploy this application. So this is a simple application that I built with using AWS SAM. So if we go into the editor, this is the source code. Before diving deep into the SAM template that describes the architecture of the function, let's deploy the function. So let's go in the terminal. I can use this simple command SAM build and SAM deploy to start the build process and to deploy the functions and all the configuration for DynamoDB and API gateway to the cloud. So this will take a few minutes. While this is going on, we can go back here and have a look at the SAM template. So here I have a first section that is the globals. Here you can put the global parameters that are applied to all the function and the APIs, in this case, of this template. So for functions, I want a timeout of 3 seconds. I don't want customers to wait too much. I enable tracing, both for all function and also for all APIs. This is using AWS X-Ray, and we will see that in the second part of the presentation. Then I'm creating the resources. And first I create a DynamoDB table, a very simple table. By default, ID is the primary key of a simple table with SAM. Then I create an orders queue to decouple the create order and the process order functions. And then I have the read order function that is the one that is reading the order from the DynamoDB table. So it needs read access to the DynamoDB table. It needs to know the name of the table. I put that into an environmental variable, and then it's connected to the HTTP GET to the function. Then I have the create order that is similar, but now I need to be able to write into the SQS queue, and then I need to be connected to the HTTP post on the DynamoDB, on the API gateway endpoint. And then I have the backend process order function, and needs to be able to read from the SQS queue and write to the DynamoDB table. To read, I just need to connect this to the event, to the SQS event, and then SAM will take care of the permissions. And then I have the DynamoDB table name and the policy to write into this table. As output, I'm providing the endpoint of the API. In this way, I can find which is the endpoint. Here I have the code for the function, so I'm not entering into the code now, but I have a create order, process order, and read order. So let's go back here, and the deployment is completed. So let's copy the endpoint, just the endpoint. And now we can move into the next section, that is testing the API. To test the API, I'm using, you can use a command line tools if you want, like curl, but I'm using Postman. That is a free tool, really powerful, that can help you test off the different methods that you might want to implement relatively easy. So let's go into Postman. And here I have a prepared HTTP post statement with the order that I want to insert. And for this order, I need to update the endpoint here. So now I'm, without HTTPS. HTTPS. And now I can, and also this part, I can just replace it. Okay. So I can try the post, and then I want to copy the domain only here. And then I can send this. So this is the first invocation for a new function. So it can take a little bit more time. And this is the order ID that has been created. If I continue to send this, I'm creating orders with a unique ID. This is generated by the create function. And let's just do this to create a little bit of load, because I need some data to show the monitoring and the observability of how this application works. Now that I created a few orders, we can also test the get. HTTP get that will read the status of an order. So let's paste the endpoint, and then let's get one of the order ID that has been created. And then I want to get the status of this order, and then I can send the request. Again, this is the first invocation, so it's a little bit slower. And then I get the status of this order. All orders were actually equal, but it's just a couple of items with two different prices. And again, I can send this, and now it's faster, and I can generate a little bit of load for the read order function. We saw that the API seems to work. What can we do next? Well, in this case, I'm processing orders. So one thing that I always suggest is when you have a business application, don't use just the platform level metrics that tells you, for example, the latency of the API, how much time does it take for a Lambda function to process. Try to look into the business results of your application. For example, Netflix, when they do a deployment, they look into the number of people that is clicking the play button on the Netflix app, how many play per second there are. If a deployment is changing the number of play per second that their customers are doing, so the number of movies or TV series that they're watching, probably something is broken in the deployment. So a business level metrics can tell you more than the platform metric if your application is working or not. So how can you create a custom metric? So CloudWatch allows you to post custom metrics, but normally this is not really easy. This was not really easy because it's expecting that you aggregate data and you don't upload data every time. For example, you upload some aggregated data of the number of orders that are being created or processed every minute or every few minutes. This doesn't work well with ephemeral environments like Lambda functions, where you can create new environment to execute more function and when we can delete functions. So how can we address that? So to simplify this, we launched the CloudWatch embedded metrics format. And basically the idea is that if you write your logs on CloudWatch with a specific JSON syntax, then we will recognize that and automatically create a CloudWatch matrix out of that information that is written in the logs automatically for you. And to make it even easier, we also published in open source a couple of libraries for Node.js. So this is the Node.js library, and you can see here how you can install it and how you can use it in your code. And also we have a similar library for Python. If you're using another language, you can just mimic the JSON. Probably it's the easiest way. If you really think you need another language to be supported, let us know. So I already put this into the code. So if we go here into the Visual Studio code and we go into the create order function and we go into app.js here, if we go here, when I create an order, so I generate the unique ID of the order and then I save the number of items that have been processed by this order. And I'm doing exactly the same also for the process order function. In CloudWatch metrics, you can set multiple dimensions that split the location of the metric so that you can have different dimension. In this case, the only dimension I'm using is the service name, but for example, you can have a hierarchy of dimensions. So the first create order metric is published by the first function, and of course the process order function is processing a certain number of items in each order, and it's published this into a different metric, a different dimension, the certain dimension with a different value. So the service dimension for the process order service. So this is the code is very easy to set up. Let's see how that works if we go in the AWS console. So let's go here into the Lambda console. Let's go in the application. So if I refresh here, I see that the serverless observability application has been deployed and there are the functions. So let's go into the create order function. I go in the console, and if I go in monitoring, I can jump straight into the CloudWatch logs in the log group for this function. So this is the log group. So just one, because there is a single execution environment for this newly created function. These are the logs. If I look into the logs here, I can expand this one, and this one is the syntax that you need to use. So the with this info parameter to create automatically the metric. So this was generated by the library in my case, but you can do the same. It's not really complex because there's lots of placeholder values and then the values that I want to publish. So let's see if this worked. So let's go now into the metrics section of CloudWatch. And we see that now we have a custom namespace here. By default, it's called AWS Embedded Metrics. You can customize. If I click here, I can see that there are two log groups because I have two services that generated. So the create and the process. And probably it's very small, but you can see here that there is some data point. And this is the number of orders that have been processed. So this is normally a little bit behind, it's not updated in real time. So now I only see 2 orders. I think I created a few more, but it will probably be updated in a few minutes. And you see 2 orders have been created and 2 orders have been processed. This is a very basic example of how you can create a business metric. My suggestion is think of the 1, 2, 3 top business metric for your application. For example, the number of order processed, the number of transactions per minute, the number of product search in your catalog, something that really shows if a specific microservice or a specific service in your architecture works as expected or not. Another thing that I would like to show you is anomaly detection. Anomaly detection means when you have lots of data, especially if something that can happen if you start to collect information from multiple components in a distributed architecture, you want to find out if there are anomalies, some unexpected behavior. And this is something that really can help you find the needle in the stack. So let's go back to the CloudWatch console. Let's just show you how this works, because of course I don't have a lot of data. So if we go here, this is the documentation for CloudWatch. I would just like to show what happens. So normally when you have a metric, you have some graph that shows the behavior of the metric. Maybe the number of orders that I process follows these curves that you see here, so that every day grows maybe during the day up to the midday and then goes down during the night, and it repeats. And maybe some day of the week I have more load, and maybe other days of the week I have less load because people is maybe doing other things. This gray band that you see surrounding the curve is what the anomaly detection algorithm is using. So basically, using the last 14 days of your data, it's looking into the patterns of the data, and the band is telling you where the curve is expected to be, and then you can flag if you're outside of this curve and create an alarm that will tell you, hey, you're outside of the expected curve. You can also define the width of this band, how thick you want it to be, using a specific number of standard deviations. So normally in statistics, standard deviation tells you how far you are from the expected value. So normally 2, 3 standard deviation are in the 67, 95%. So 1 is 67% probability to be within one, and then it grows. So normally I would suggest you to use 2 or 3 standard deviations, depending on how many false positive or false negative you want to catch. So how can you create this? Let's go back on the CloudWatch console, and here I have my my metric, and here I can see the metrics that have been graphed. And this is the period, it's 5 minutes. It's probably one of the reasons why it's just an average on a specific time set. You can replace this with minimum, maximum values, or more importantly, for example, for latency or this kind of values, you want to use P numbers like P99 or P99.9, like percentiles. But in this case, I want to show you the anomaly detection. So if you go here, you can click on this graph here, and this enables the anomaly detection for the first metric and now also for the second metric. And now the algorithm is starting to collect the information from the last 14 days. It's what CloudWatch stores automatically and building the model. And you can also build an alarm if you want. So if I click here, I can say this is the number of orders that I've processed by the process order function. I want to create an alarm, and instead of doing a static alarm where you have to give a fixed number that if you are above or below this number you want to be alerted, you can select like here anomaly detection, and then you can say I want to know whenever I'm outside of the band, or only if I'm above or below the band, so greater or lower. And here you can set a number of standard deviations. So 2 is a good starting point. It should be about 95% probability if you have a normal distribution, but probably 2, 3 is the values that I would use to avoid too many false positive. My suggestion is when you create an anomaly detection alarm, don't connect it to something too powerful immediately. Wait for a few days to see if it works as expected. So let's, for example, create this alarm. And then in case of alarm, I want to be notified, maybe I want to create a new topic, and I want to receive something in my email. Okay, and then I can say next. Let's call it, this is for the process order anomaly. And then we can create the alarm. And I have multiple alarms. If I go back into the metrics, I can create an alarm also for the create order, similar to this. So outside of the band, to anomaly detection, like this. So let's use the same topic, and then let's call it create order anomaly, and create the alarm. So now I created 2 alarms. They have insufficient data now, but if the application starts to be in production, I can start to use them and understand if they work or not, depending if my the behavior of the metrics is really something I can estimate or not. Composite alarms. This is another interesting idea. So normally with CloudWatch you can create multiple alarms, and when you create these multiple alarms, you can be alerted when each of them fires. But sometimes you want to understand if there's something more complex here. So maybe you want to understand if 1 out of 3 alarms fires, or only if 2 alarms fire at the same moment. So you want to compose multiple alarms together to create a sort of higher order alarm. And this is a relatively new feature that we added to CloudWatch. So if we go back to the CloudWatch console, and this time we go into alarms. I'm already into alarms, okay. I can select, for example, I can select these 2 alarm that I just created for the anomaly. And then I can click here on create composite alarm. And this will create an alarm where by default, if I select multiple alarms, they are connected by an OR statement. So if any of these fires, then I receive the alarm. This goes into the alarm state. You can also be selected if one alarm, for example, is not in alarm state here. So you can choose another state, or you can replace this with AND. And you can also use parentheses and connect this with other alarms. I think you can use up to 100 alarms in the condition that create a composite alarm. So the idea here is really to maybe learning from previous events, understanding if some pattern should be escalated differently, and then create this composite alarm that can help you understand immediately if you are again in that kind of situation. So for example, maybe if the latency is very low, normally it's a good sign, but maybe it can be a bad sign because the latency of my API is very low because another API that I use inside my function, this is an external provider, is failing very quickly. So the function are failing very quickly because of that API and returning a wrong value. So if you can connect this with a custom metrics that tells you if this function is actually working, you can say, oh, actually the latency is good, but it's too good to be true. And actually I'm seeing that there is a very low number of order that is being processed. I want to be alerted. So let's go back to the syntax. Let's use an AND, and let's create this composite alarm. So the alarm state, in case I want this to go into alarm, if they are both into alarm, I can again use the same topic as before. Maybe you want to be notified only in case of the composite alarm. And let's call it a composite anomaly. Okay. And in this way, now we have created our composite anomaly alarm. Now it's okay, but there's still everything is with insufficient data. So we should wait some time and generate more load. Another important topic for this kind of observability strategies is how can I analyze logs? So we added this capability to CloudWatch logs, I think 2 years ago, and it's CloudWatch logs inside. So if I click here in CloudWatch logs insights, I can select one or more log groups. So let's search for observability. So all the logs for the observability function that have observability in the name. So in this case are the first 3 as the 3 lambda function of my stack. I can select them here, and then I can create a query. There is a specific language to run queries, but we have standard queries for different logs like lambda logs or VPC flow logs or CloudTrail logs. For lambda queries, for example, I can see the latency statistic with a 5-minute interval. I select this, I run the query, and we should see some statistic of what we did when we deployed the application. You can see the latency here. It's very low because it's a simple application. But if you have lots of data, it will show you how the latency every 5 minutes is going. It's currently showing the average and the max. So the max normally shows the cold start for Lambda function and also the min. And you can change the bin size from 5 minutes to whatever you want, maybe something more coarse if you have a lot of data. And here we also have one of my favorite, that is the another query that determines the amount of over-provisioned memory. So each time a Lambda function is executed, it reports how much memory of the allocated memory was actually used, and you can use this information to debug this. So this is the syntax that we're using, and here you can, if we run the query, you can see how much memory was used and how much was not used. So it's if we look here, we see that the provisioned memory is how much was used on average, how much we used maximum, and the amount of over provisioned memory. In this case, it's not a lot, so I was giving, I think, the minimum 128 megabytes. It's just some Node.js code in my case, so I just need some memory for Node.js interpreter, and I was not using everything. You can over provision your function to give more CPU power, so it's not, doesn't mean this that it's a wrong configuration, but it can help you understand. Even if you're giving more CPU power to your function and you're not using all your memory, but it's okay, you can still decide to use that memory for some, for example, local caching. You can cache some number in memory. It can help you speed up your function. It's just an idea. Third sample query here is the find the most expensive request. So this can be useful if you want to find the most expensive request. Normally those are, in my case, the cold start for the tree function, the only one that go above 1 second, but it can help you again debug your functions in production. Of course, you can customize these queries, and for the standard logs that we provide, like Lambda logs, all these fields that you see here on the right are automatically discovered. So timestamp, memory size, it's very easy to collect information and extract information from standard logs that are understood by this tool. Tracing. Tracing is really important. Tracing means that when you have a distributed architecture, like it happens with serverless application, you want to understand what happens when the requests arrive, maybe through an API gateway or something, then are routed through multiple Lambda functions, and then use different other components like S3 buckets, DynamoDB tables, and so on. You will really understand the overall flow, and if there's some bottleneck, if there is some issue here or there. So how can you do that? So there are some tracing tools, and in this case, I'd like to introduce you to AWS X-Ray. So AWS X-Ray is a tool that you can use to monitor. It's completely integrated with Lambda and the API Gateway REST APIs. So if we go back, for example, here in the Lambda console, you can see that in the configuration, X-Ray was enabled, and this was enabled because if I go back in the template, I was giving in the global, I was using in the global this value for function, so the tracing was active, and also this was enabling tracing for the REST API. And if we go here back to the X-Ray console, we can see that we're building now a map. I'm using the data from the last 30 minutes, and this is what is happening. So you see that you have a client that is calling this API stage, and then it's going to the create order or the read order function, and then the read order function is reading from the orders table. And here you also have the path that writes into the SQS queue. And the SQS queue is what happens here, is giving an input to the process order, and then the process order is writing in the DynamoDB table. Currently, when you use SQS, X-Ray is supported, but with Lambda, since Lambda is automatically creating a segment is a single trace that you follow in the tool. It's splitting the two interactions in two. We're looking into ways to improve that, but already in this way you get a nice idea of what is happening. So as you see, I'm not seeing only what Lambda and API gateway are doing, I'm also seeing what the Lambda function is doing. So it's calling SQS, it's calling DynamoDB. The reason why I see that is that if I go back in the code of the function, like this is the create order function, when I'm using the AWS SDK here, I'm actually wrapping the AWS SDK inside the AWS X-Ray SDK. So the AWS X-Ray SDK is capturing all the AWS SDK, and then you get an object that you can use like normally. So then I can create, for example, SQS here, or in the process function, I'm creating the DynamoDB object. So you don't need to change your code, you just need to replace when you require the AWS SDK in Node.js or in any language, when you import the AWS SDK module, you need to wrap it into the AWS X-Ray modules so that it's wrapped and all the invocation will be monitored by X-Ray. Actually not all, because with tracing normally you do sampling and you can configure, depending on your load, which percentage of invocation you want to sample. So maybe 3%, 1%, 5% is enough when you reach a specific volume. So let's go back to the X-Ray console. If I go here, you see the single traces of, for example, the HTTP post or the HTTP GET, so those that have been sampled. And if I select one of them, I can see the detail of what happened here. So there is the API gateway stage is calling Lambda, and then this goes to the Lambda platform, and then the Lambda platform is executing the Lambda function. So this is the final part is your code, and the code has an invocation. Sorry, let's not look at this, to SQS. This is one OK, and this is the time spent to send the message. And then there's also the information for SQS here that we can see, for example. Let me make this visible more. And here on top, you see also the trace map. This is a new feature that we launched at the end of last year. So you can now see for each single trace the map of what happened here. You can also put the service icons if you want to see this in an easier to understand way. And you can check the health or the traffic. If you go here in sampling is where you can define the sampling rules for your application. So in this case, until I reach a certain load, I take everything and then I go to a 5% fixed rate of sampling. So 5% of the invocations are sampled by X-Ray above 1 per second. So it's very low threshold. So if we look at this, the feedback that we get from lots of customers, the service map is really good, but I would like to connect this information to the information that CloudWatch has in the logs, in the metrics for Lambda functions, for DynamoDB, for S3. So how can I do that? This is something that we worked last year, and currently in preview we have launched CloudWatch Service Lens. So if I select here in the CloudWatch console service lens, I can see the service map. This is in the automatically targeting the last 6 hours. I can zoom full screen so you see a little bit better. And this is a similar graph to what you were seeing before, but now if I click, I can get all the information. So for example, this is the API gateway stage, this is the latency of the request. If I get error, I can select the Lambda context and the Lambda code. And if I click here, I can also go and jump to the CloudWatch logs. It's automatically going to CloudWatch logs inside for that function, and I can then run the queries that I was seeing before to see the latency of this specific function only, how it's behaving, the average duration, the max and the minimum duration. So CloudWatch Synthetics is really useful because it's connecting the information from X-Ray, from tracing, to information that you have in logs and metrics. And these are some of the 3 pillars of observability. So having everything in the same console, it really helps you debug any issue in a much faster way. Last point I want to show you today is synthetic monitoring. So when you have a distributed architecture, multiple microservices, it's good practice to create synthetic transactions that you can test periodically and see if they work. It's a good way to monitor the external endpoint of your overall architecture or your microservices. In this way, you can really understand where, if something fails, where it's failing, and react very quickly. And to simplify this kind of approach, we introduced a new feature to CloudWatch, and it's called CloudWatch Synthetics. And with CloudWatch Synthetics, you can model your web applications in lots of different, and your APIs in lots of different ways. So you can create what we call a canary. This is your synthetic transaction, and you can customize with your code, is JavaScript code, how you want to test your application. And we have some blueprints, so you can use blueprints to do a simple heartbeat to see if a URL works and returns 200 OK. You can test an API, and this is what I'm going to do with our API. You can check a web page for broken links. So we scrape the page with a crawler and we look if there's broken links. Or you can also follow a multi-step process. So if you have a graphical user interface in a web page that allows you to, for example, log in, then select some items and then do something with those items, maybe create an order. You can do that. So you maybe create a fake user in your database for testing purposes, and then you can test the full transaction. For each of these blueprint, like the API blueprint, you can give a name. So this is my test. I want to do an HTTP GET, so I don't create order, I only test that the GET works, but you can do something more interesting if you set up something that is ignored in the application. So if you create, this user creates an order, it's not to be processed. And then I need to give the endpoint. So to get the endpoint, let's go back to the terminal. Let's copy again the endpoint. But I want to do a GET, so let's use Postman. And let's do exactly, let's copy the full GET to this order ID. If I send, it works. It gives me back the specific order. So let's go back to the page and use this for the HTTP GET. You can customize headers. Maybe a specific header is telling you to ignore this order at some point. And this is the script editor. For each of these 4 blueprints that we provide, you can customize the code is JavaScript, and depending on your application. In my case, to test an API, I don't need to customize anything. I just need to run this. You can run this canary continuously or run it just once, like in my case. And you can set up a maximum timeout if you want. And then you can automatically set up data retention so that all the logs are archived in an S3 bucket that is created for you. And I will create automatically a new role and leave all the other settings by default because I don't need the VPC setting. This is on the public internet. So normally it takes up to a minute to create this, and when it will be created, I have the canary. You can schedule that automatically. In my case, I will have to trigger it manually, and it will test my API. I see that if we look into the code is not something that you can see now. You can see the code. It's actually testing that the status code is from an HTTP perspective is 200, so it works. Another minute and another few seconds and the canary is ready. This is the classical demo effect. Okay, success has been created, it's here. I can just go here. It's starting and running automatically, and you can see that it is being passed. So it's run automatically. And then I can run it automatically when I want. You can also run that through the CLI or the AWS SDK, or as I said before, you can schedule it so that it's automatically checked every few minutes or once every hour. So as you saw, even with such a simple application, observability is critical because there's always lots of moving parts with serverless architecture, and you need to have an observability strategy that helps you understand what is happening. Normally, you need to collect your logs, you need to create custom business metrics that tells you if your application is working from a business perspective. You have to set up your alarms, and you can use anomaly detection to automatically detect unexpected behavior. If you have lots of data, anomaly detection and machine learning can really help you find the needle in the stack. And You can also use tracing. So tracing is really paramount because when something happens, if you don't have the tracing information already collected for a sample of the data, it's really difficult to debug and find the bottleneck, for example, that is slowing down your application. Maybe it's the process order or it's the create order. You need to see where's the delay and then drill down. So on a platform like CloudWatch, Service Lens allows you to drill down from the tracing view into the logs, into the metrics, and also think of the external behavior of your application. So synthetic transaction really can help you understand if everything is working from an outside perspective. And this works for the overall application, a web application, or for the single API of your microservices. If you want to play with this sample code, this is my GitHub account where you can find the code of this very basic application, and you can replicate what I did and test and see if it works for your use case. Thank you.